Alright guys, this video is going to cover 11.5 and 11.6 for test 5. This is a really important part. This is stuff you'll take on to your other math classes, so you really need to kind of make sure you understand. You can have quadratic equations written in either of these forms. So you could see them in standard form, you could see them in what is called vertex form. I encourage you not to switch between the forms. Don't change something that is in standard form to vertex form or vertex form to standard form, because there's ways to deal with them in the form that they're in. So this video is going to kind of talk a little bit about that and go through the steps with you. So all of these equations are considered standard. They can all be set to 0. So this equation right here, I had to add 8 to both sides to get it set to 0. Once we have them set to 0, we can factor them. Multiplies to give you 12, adds to give you 7, and solve. When we do that, that helps us find the x-intercepts, which we know from chapter 6. So we can factor to get x-intercepts when it's in standard form. If we can't factor, we can use the quadratic formula if we know a, b, and c, and that will also give us our x-intercepts. So x-intercepts is one of the most valuable things that come from standard form through factoring really easily sometimes. When it comes to vertex form, it's really easy to see how a graph is moving. You know, we did this in Unit 3. I can look at something in vertex form and I can see that it's moving left or right or up or down. If I know that, then I can find the vertex really easily. That's why it's called vertex form. So for instance, this first one, I know that it's going left 3 and down 5. That means that it has a vertex of negative 3, 5. If it only goes right 4, then this vertex would be 4, 0, because it doesn't go up or down. This vertex here would be 0, 7. All it does is go up or down. In this case, up. I can fix that. 0, 7. This graph only went up 7. It never went left or right. So when it's in vertex form, it's really easy to find that vertex if you can remember how it moves. If you're going to want to find the x-intercepts when it's written in this form, you're going to have to set it equal to 0 and solve it like an equation. And I'm going to go over that with you in some other examples. But I just wanted you to notice the difference between forms here and why both forms are valuable. At the end of the day, you can do everything you need to do with either form. This last example would be considered written in standard or vertex form. I can get an A, B, and a C from it if I want to use quadratic formula, and I can tell how it's moving because of the way it's written. This doesn't go left or right, but it does go up. So sometimes you could consider them as either form. So let's look at how to do this, how to actually get everything we need and graph. The important things you're going to have to know how to find are vertex, y-intercept, x-intercepts, and how it opens. Sometimes the questions will only ask you for portions of that. Sometimes it will want all of that. So they may not ask you all things in one question, but you still should know the method for finding it. I'm going to do standard form first, okay? I think it takes a little longer sometimes when it's in standard form. So we're going to go over some examples. I've already done these, but I'm definitely going to post them on Blackboard for you to be able to look at, okay, to find the steps. So I see that I have standard form. Anytime you have standard form, there's 2 steps for finding your vertex. So that's the part in purple right here. It looks blue in the well, blue in the screen, okay? The two steps for finding the vertex, first you've got to find the axis of symmetry. That's what this is called. It's abbreviated sometimes AOS, axis of symmetry, okay? That's just the imaginary line that's in the middle, and I'll show you that in a minute. So first I have to do this formula, x equals negative b over 2a. So this is a formula that you need when you're finding the vertex and it's in standard form. This is the axis of symmetry. Alright, so 1 is A, B is 7, and 12 is C. So when I plug in negative and then B is 7, the sign should always change on your B. So that's why B was positive, but if it's negative B in the formula, it's going to be negative. So negative 7 over 2, that gives me negative 3.5. I'm changing it to a decimal because the second step for finding your vertex is to plug in the axis of symmetry to the original equation. So now I have to plug in negative 3.5 in for each x and use order of operations and get my y. So you put your x and your y together for your whole vertex point. Left 3.5, down 0.25. That's a point you can plot. Alright, so x-intercepts. That means I'm going to set it to 0 and see if I can factor. This one could be factored, so my two x-intercepts are negative 3 and negative 4. X-intercepts mean that they're on the axis, so the point that you plot will always have a 0 in the y place. So now I have 1, 2, 3 points I can plot on my graph. Anytime I want to know the y-intercept, I'm going to plug in x equals 0. So 0 squared plus 7 times 0 plus 12. And people realize that when it's in standard form, there's a little shortcut you can take for the y-intercept. Because if I plug in 0 where there's every x, then it's going to make both of these 0. And the only thing left is 12. So the c term, if it's set to 0, the c term is always going to be your y-intercept if it's in standard form. And this point would be the point 0, 12 on my graph. Okay, so now I have 1, 2, 3, 4 points I can plot on my graph. I know that it opens up because A is positive, and the very front of my equation is positive, so I know it's miles. So I just plot the points that I have. Here is left 3.5, down a half. Here's negative 3 and negative 4, my x-intercepts. In the very middle, if I drew that vertical line, that's your axis of symmetry. That's that line that cuts the middle of your shape. And I have enough to graph. Okay, so this walks through another one. Same steps as we did before. For this particular problem, you could factor it or use the quadratic formula, but it's going to be split the middle because you got LC greater than 1. So if you factor, you're going to have to do the split the middle method to get those x-intercepts. Or you could use quadratic formula if that's easier for you, if you don't want to factor using LC not 1. But you should be able to follow my steps and see how I did axis of symmetry, negative b over 2a. Got to start with that. I got negative 0.5 and I plug that in. This is an important part right here. A lot of people get confused because they forget to do the negative 0.5 squared first and then multiply by 4. So watch out for order of operations. And you can ask questions in the Q&A about this. Alright, so the next thing I want to do, I want to show you, both of these had X-intercepts. So I'm going to show you one that does not have any X-intercepts. The reason I know that is because this would be multiplies to give you 5 and add to give you negative 4. And there's nothing that does that. So I know that I'm not going to have any X-intercepts here. You can't factor this. And if you put it in the quadratic formula, it would give you a negative under the square root, which means not real solutions. So your discriminant, which we learned about in 11.2, is negative. So I know that's another reason why I'm not going to have any X-intercepts for this particular problem. That means less points to be able to plot. So that's why I want to talk about this. I'm still going to go through the steps for finding my vertex. X equals negative b over 2a. Plug it in so I get my vertex. I know my y-intercept is 5. So I can plot 2, 1. I can plot 5 on the y-axis. A lot of times they want 3 points though. This is when understanding the axis of symmetry is going to mean a shortcut for you. If I know that that line cuts my parabola into 2 equal halves, then any point on the right side has to be symmetric to the left side. So I know that I have a y-intercept at 0, 5. I know that for sure. If I look directly across, I should find a mirror image. Well, the point 0, 5 is 2 units from this axis of symmetry. That means if I go over 2 more units on the other side, that is the symmetric point in the graph, so that I can have 3 points. So try to use symmetry sometimes to get the another point if you need to, because the only other way to do it is to pick a number and plug in the equation, and I think that that takes longer, but I'll talk about that in another example. Okay? Alright, so then let's go to vertex form. So here's a vertex form example. Well, here's my equation. I can see from this equation that it goes left 1. That means moving left 1. This means up 4. So if I move into the left 1 and up 4, how is it moving? That tells me my vertex. So my vertex would be negative 1, 4. This is why we always say opposite sign inside parentheses. It was plus, but it's really moving to the left. I never did use negative b over 2a because it was not in standard form. I didn't need to. But no matter what, this first number of your vertex is always the axis of symmetry. So don't let that throw you off. If they ask you for axis of symmetry, that doesn't mean that you always have to do negative b over 2a. If you know the vertex, the first number is the axis of symmetry. So for y-intercept, I've got to plug in my 0 now. There's no shortcut on the y-intercept for vertex form. So I've got to plug in the 0 for x and do order of operations to get the y-intercept. Okay, so I've got a vertex, negative 1, 4. I've got a y-intercept of 5. I know it opens up because it's positive in the front. So I have enough to graph this one, plus it doesn't have any x-intercepts, and I'm going to prove that in a minute. This is my vertex, negative 1, 4. My y-intercept is 0, 5. That's 1 unit away from this axis of symmetry that cuts the middle. So I know my other point is 1 unit away on the other side. Okay, so how can I prove that there's no x-intercepts? So I mentioned in the previous notes page, you've got to set it equal to 0, but you don't factor, you solve. If I set this equal to 0, the first step is going to be to subtract 4 on both sides. Well, then I come down and I know that the opposite of the square power is to take the square root of both sides. Immediately, I see that I can't do that. We can't take the square root of a negative. It's an imaginary number. It's undefined. So the minute that this happens, I know I don't have any x-intercepts. I can just stop. Okay? The next one I show you, and you can see it opens up so it never touches the x-axis. The next one I'm going to show you, it will have x-intercepts. So, let's see, you got a negative in the front, so I know it opens down. They call that reflection. Opposite sign, because it's inside parentheses, so I know this one is moving to the right 3. There's no number on the outside, so it doesn't move up or down. So that means my vertex is just 3, 0. I plug in 0 to get my y-intercept. Be careful here, because this is negative 3 squared, which is a positive 9, and negative 1 times that. So it's actually negative 9. So I have my vertex, I have negative 9. I can use symmetry to get my third point. So if negative 9 is 1, 2, 3 units away from this AOS, then I know I go 3 units on the other side. And you may look at this and say, well, no, it doesn't have x-intercepts. It's just a vertex. Well, I can still show you how it would solve, and you could keep going. I set it to 0. I divide by negative 1 on both sides to cancel those negatives. I take the square root of both sides. I can take the square root of 0. Square root of 0 is 0. This just leaves x minus 3, and then I add 3 to both sides. I only have 1 x-intercept. And we know that this is another case of your discriminant in 11.2. That's why it only touches the x-axis once. It kind of hangs from it. That's the case in your notes that I drew for you, because it's 0 under the square root. So this is how it kind of, one looks like if you know, if it's not a negative. And I'm going to show you another one too. Okay, so I'm going to graph this one with you, because I don't really even want to just say lab, because this might end up being on your test. But sometimes there's a number in front. Now, you're not going to have to name it. This won't be on the test. But whenever there's a number, a coefficient that's not 1 or -1 in the front, and it's in vertex form, it means that there's vertical stretch or shrink present. It means that your parabola is going to be skinnier or more narrow or wider, okay? That's just information for you. You're not going to have to say vertical stretch or shrink, but that's what makes your graph wide or narrow. So if I look here, I can still get my vertex because this is left, right, right. So this is right 3 and up 4. So I know that this is my vertex. I know it opens down because it's a negative. I can plug in 0. 0 minus 3, -3 squared is 9. This is my y-intercept, so there's a point at 0, -14. But a lot of times you don't have, your graph only goes out to 10, which means I can't even plot this. So let's graph this together. So I can't plot the 0, -14, so let's look at what I can do. So I can plot 3, 4. So 1, 2, 3, 1, 2, 3, 4. It opens down, right? So it does have X-intercepts. So let's look at how that works out if we were to solve it. I'm going to step away from the graph real quick. So let's set this equal to 0 and see what happens. Let's see. And let's solve this. So -4, -4. You always work order of operations backwards when you're solving an equation. So usually you don't do addition and subtraction until the end. Please excuse my dear Aunt Sally, but if we're solving an equation, we're going backwards. So we're going to do the addition and subtraction part first. Then I'm going to divide, multiplication and division. So I'm going to divide by -2. So that gives me +2. 4 divided by 2. I know I take the square root of both sides. So this should be similar to like 11(1), I think is when you did the square root property. So that just leaves me with x minus 3 on the left, plus or minus 2. And then to finish it, I would add 3. X equals 3 plus or minus radical 2. Well, those are x-intercepts, but they're not going to be pretty to plot because it's a decimal. So technically speaking, I could put in my calculator 3 plus the square root of 2, and it gives me 4.4. And then I could do 3 minus the square root of 2, and it gives me 1.5. But those decimals I'd have to round to use, so it makes it a little bit harder. So I want to show you how another way that you can get your points. But this just shows you an example of how I could keep solving. These are x-intercepts. They're just never-ending decimals. Okay? Sometimes they call those irrational in your textbook. Never-ending decimals with no pattern. That's what irrational is. And so that's why they're kind of harder to plot. I'd have to round them to plot them on my graph. So if I go back to my graph, let's say I wanted to do, something to get some more points. Then I need to pick a number on both sides. I need to pick something to plug in, right? Well, this is my axis of symmetry. So as long I'm going to pick something to plug in, I'm going to pick the point 1, x equals 1. It's on the left side of my center. And I'm just going to plug it in and see what I get. So I'm going to use x equals 1. And let's see, y is equal to -2, 1 minus 3 squared plus 4. So that's going to give me -2 times -2 squared plus 4. So that's going to give me -2 times 4 plus 4. So that's -8 plus 8. So that's 0. So that means there's a point at 1, 0 on my graph. So I come over here and I plot that point. Alright, did you catch my mistake? I just wrote plus 8 there for no reason. And I immediately knew it wasn't right because I'm not supposed to have nice, neat whole number X-intercepts. So that's what stopped me. I was thinking that this was -8 too quick, going too quick. So this is plus 4. Right, it was always plus 4. So that's going to give me okay, so I brought it down. So now it's -8. -8 plus 4. So that's -4. So then the point is actually 1, comma, -4. Okay, so now I go to my graph. Fix it. Okay, so now I'm going to plot the point 1, -4. So here's 1, 1, 2, 3, 4. Now, the reason this helps me is because I only need 1 point on one side, and then I can use symmetry. So I picked 1 because it's an easy number to plug in a lot of times. I knew I couldn't pick 0 because I already had my y-intercept, and it was down at -14. I can't plot that. So I picked 1. You could have picked 2. But I just chose 1. So if I pick 1, then I know if there's a point that's 2 units away from the axis of symmetry here, then I know it's also 2 units away on the other side. And now I have enough to draw my upside down reflected parabola. Okay? So I hope you can see that there's a lot of different ways and strategies that you have to use sometimes in order to get your overall graph. Some graphs have x-intercepts, some don't. Some have y-intercepts you can plot, some don't. So it's really important that you are aware of the different strategies that you can use to find different parts of your graph. I'm going to post more examples than what I went over with you today under notes on Blackboard. And again, make sure you ask any questions that you feel like you need to ask in the Q&A. I'm going to do one more video, and it's going to be short. It's going to have to do with word problems.